Hi everyone, over the past few weeks we've learned a series of Linux commands. Now, as you can imagine, a lot of the time these commands need to be repeated, they need to be run multiple times throughout a day at different periods. Therefore, to have someone actually sitting manually typing them in at a terminal just isn't going to work. So what we can do though is we can actually put the commands inside a script, in this case a Python script. This then allows us to control and put conditions against when the commands are executed, and we can also schedule them as well. So it makes much more sense rather than having a user sitting at the terminal all the time. So this video is basically going to take you through Activity1, Python Scripting 1, which is just a tutorial introduction. So I'm going to walk you through to make sure everybody understands how to use Python within Linux. So let's just get started. Okay, so first of all, we should all be logged in just as normal. I've logged in as root, doesn't particularly matter, we're not doing anything that requires any great level of permission. So logged in to our terminal. First thing, let's do a few setup tasks. So we're going to be creating some scripts. So what I want to do is create a directory to store these scripts in. So I'm going to go into, I've got a demo files directory. So I'm going to change directory CD into that. And then in here, I'm going to make a directory for my Python scripts. Make dir Python scripts. And I would recommend that you guys do this to keep everything nice and tidy and organized in your file structure. So make dir, make directory Python scripts. Then I'm going to move into that directory. So CD, change directory into Python scripts. Within here, again, I would recommend that you make a directory for each activity because the activities have multiple tasks within them. So this time I'm doing activity 1. So make dir activity 1. And again, I'm going to change into that directory, CD activity 1. And in here, I'm going to be using some commands that list the contents of the directory. So I'm going to be using the ls command inside the Python script, but right now there's nothing in this directory. So to make it obviously a bit more interesting and worthwhile, I'm going to create some files and a directory just to populate it. So quick way to create files that have no content, but at least they're registered as files, is a touch command. So I'm just going to do, oops, shouldn't talk at the same time. So I'm just saying touch, which basically just means create these 3 files called file 1, file 2, file 3, and they'll have 0 file length. If I do an ls-l, you'll see that. So they're just empty, but at least it gives me something to use for this task. I'm also going to create a wee directory, make dir test, just so I've also got a directory in here as well. So now, if we have a look, I've got 3 files and 1 directory. Okay, let's now look at writing our Python script. So the command line editor you've learned in the past week is the VI or Vim editor, and as you're aware, it's quite challenging to use this editor. However, it's very important as you can always guarantee that it ships with the Debian distribution, so it'll always be there for you. We're not going to use it because some people do find it quite challenging and quite time consuming. So we're going to use another editor, which is mentioned in the slides. It's really important you've read the slides prior to doing this activity. And the editor is called Nano. To find out more about it, there's a link in the slides. It's worth having a read at. So Nano doesn't always ship with the distribution, which is why we can't rely on it being there, which is why we still need to have the core skill of VI. But we have got Nano installed in the distributions that you all have of Debian. So to launch Nano, we type Nano, and you'll see that the taskbar's changed to say it's on Nano. It's under the GNU license, so it's free and it's shareable. So remember as well, I've got this screen maximized, so this is where you're going to type in this black area. But if I scroll down, you'll see at the bottom, it gives you hints of the most commonly used commands to carry out steps within the editor. So to be honest, really all you need to remember is Control and O for writing the file and Control X for exiting. That's all we really use. Okay, let's get started. So First program we're going to write is just basically what we've just done in the command line. We're going to write a Python script that lists the contents of the current directory. Obviously though, we're within a script this time. And what that means is we can run this script as many times as we want. We can schedule it as well. There's a scheduler available that we can use, so it can run at certain times in the day, etc. So it saves us having to sit there typing it in all the time. First thing, you should start with comments. I'm not going to type in lots of comments on this tutorial. The comments are in the examples in the activity sheets. I also will be here a long time if I've got to type in all the comments. First job, anytime you want to execute an external command from within a Python script, we need to use a special module called subprocess. So subprocess contains already pre-written and tested code that does this job for us. So we're going to import the module. So import subprocess. Previously, C++, it would be the same as doing hash include to bring in a library. C#, it'd be the same as saying the using statement to bring in a library. It's just code that's already been written and we're going to use it. So we've imported the module. The next step is we need to actually write the subprocess command. So when we write the subprocess command, we need to be able to capture the output, because by default it'll execute the command in the Linux environment, and under normal circumstances, as you saw, the output would just go straight out to the screen. But we want to actually capture it and store it in our Python script, so then if we want to, we can analyze it or we can do some stuff with it. So to store it means we need to have a variable to basically record what the output is. So I'm just going to set up a variable called ls_output because it's the output of the ls command. And now I'm going to type my subprocess. So subprocess, the function we're using within this module is run, because we're going to run a command. We want to execute an external command. There are other functions available in the subprocess library, but we won't be covering them as part of this course. So subprocess.run is a function, so as always has function brackets, and then we're going to put our parameters inside these brackets. So we need to tell it what command to run. So the command we want to run is just the Linux command that you've been learning over the past few weeks. So all of the Linux commands that you've learned are perfectly valid. We do, however, surround them in quotes. So there's the ls command, and I've added in the -l to give it a long listing. So that is literally just the Linux command surrounded in quotes and put into brackets. Now if I left it like that, we'd have a bit of a problem because it wouldn't be able to take the -l. It would only take the ls. So what we need to do is we need to tell it that we are giving it the whole command inside this set of quotes. So to tell it that, we have a special property called shell equals true. So this is basically saying that please take everything inside the quotes, that is the full command. So it doesn't stop after the bit of white space. So we're saying shell is true. Now again, please read the slides, this is all explained in the slides. The other thing we need to set is a property to say that we want to capture the output. If we don't capture the output, it will go to standard out, and we don't want that to happen. We want to actually capture it in our script. And finally, the last one we need to set is another property called text equals true. When we capture the output, it captures it in its binary format. So we want to make sure we output it, or we capture it in its actual original text format. So anything that's output by the command in text, we are going to capture and store in this ls_output variable. Okay, so that'll run the command, and whatever's output from running that command will be stored in the ls_output. So now we're going to print out whatever is inside ls_output. Now if we left it like that, it wouldn't work, because what's actually returned is an object. So it's an object that's returned. So it tells us quite a lot of information. We can ask the object which text was returned. We can ask it for any error codes. We can ask it for error messages. So basically a whole load of information is returned about what happened when we ran this command this ls-l command. So we need to say that we want to get to display whatever was displayed to standard out. So that's the final part of the script. So once we're done, we need to do control. So hold down your control key and press O, not 0, the letter O. And then I need to scroll down. So I see the bottom of the screen and it asks me what do I want to call the file. So I'm just going to call it task1.py, hit return, and then the editor's still open. So control, hold down control and press X and it'll exit. Say you made a mistake and you want to go back in and look at the file, call nano again and you can actually give it the name of the file you want to open. So I need to scroll up and you'll see there's the file we've just edited. Okay, so control X, I'm just going to come out of that again. So now that we've written our file, we want to go ahead and execute it. So to execute it, we need to call the Python interpreter. Now this is really important, and I've mentioned this in the slides. By default, the Python that's installed, there may actually be multiple versions installed. So you can do a Python -- version to see what you've got. So this says that it's currently set up to use Python 2.7.16. Now this is an old version. I know that Python 3 is installed in this. So in order to make sure I use the Python 3 version, I need to call Python 3. You can change the environment variables to switch it from referring to Python 2.7.16 to switch it to Python 3, but again this is beyond the scope of the course. So to make sure you're using the right version of Python, it's Python with the number 3 immediately after it, no spaces. Then that basically calls the Python interpreter and we need to pass it the script we want to run. So we're going to say pass it task1.py and run that script. That's another thing, and I made this point in the activity, save all your Python files with a .py extension. Okay, so when I hit return, there we go, it has long listed the contents of the directory, and you can see file 123, the actual Python file and the test directory as well. So that completes activity 1. Or task 1 of activity 1. So now we're going to have a wee look at task 2. So sometimes we need to pass information into the Linux command. It needs an argument. So a good example of this is that if I wanted to list the contents of a directory, so right now if I wanted to list the contents of the test directory, I would need to say ls, and if I just left it as ls, it would just give me the current directory. So I would need to actually give it the argument ls test, the name of the directory I want to list the contents of. Now right now there's nothing in test, so let's go in there and let's create some files. Okay, just create 2 files this time, back up a directory. So if I want to list the contents of test, I would say ls and then the name of the directory, and it tells me it's got 2 files in it. So that command had an argument. The argument was the directory name, which was test. So we need a way in our Python script to be able to pass information into the arguments of a command. And that's the next thing we're going to look at. So the next activity is going to be, again, listing the contents. But instead of just doing ls-l to list the contents of the current directory, we are going to give the user the option to input the name of the directory they want to list the contents of. So let's create a new file. So we're going to have task 2. So I'm just going to open nano with task 2, which doesn't exist, so it'll just create the file. So again, scroll up so you can see what I'm typing. So import, we need that subprocess module. Every time you use subprocess, you need that subprocess module. I've put in an extra space there. Yeah. Okay, so the first thing we need to do is we need to actually get the user to enter the name of the directory they want to list the contents of. So we're going to ask them for input, so we're going to use the input command, and we need to store that input. So again, I need a variable to store the input. So I'm going to use a variable with the name directory, and it is basically going to store the input of us asking the user, so please input the name of a directory. Okay, Nice with the syntax highlighting. Helps a lot. Helps you spot any typos. So now we've asked the user to enter the name of the directory using the Python input command, and by default it'll read in whatever the user types and it'll store it in this variable named directory. Now we're going to do the subprocess.run command again, like the one we just did. So remember, we need a variable to store whatever the result is. So I'm just going to call it ls output because it's output of running the ls command. So again, same subprocess.run, and then we put the Linux command in quotes, so ls-l. Now this time I want to say ls-l and then the name of the directory. So I need to pass that name of the directory into the Linux command. So to do that, I need to put in a placeholder. So the placeholder is a percent substitution variable, call it. So basically this is saying that here's a command and you're going to have this value at the end that you'll need to get from your Python script. So you have to know what the data type is of the value. So it's just the directory, it's just a directory name, so it's just a string. So it's %s. If it was a number, I would use %d. So this says list, long list, long list, and then whatever this variable is that's been passed in. So in this case, the directory name. Close the quotes because that's the end of the command. Then we need to say where it can find that substitution variable. So we put in a percent to say here's where to find your substitute variable, and you can find it in the Python variable called directory. So all it will do is it will just run ls-l and then whatever is stored in that variable directory. Okay, so again we need all the flags to be set. So we need the shell to be true, equal to true. We need to capture the output, and we also want to capture the output in text format. So set all these properties to true. Okay, and then again we want to display to the screen, so Python print whatever's returned, so the ls output, and again remember it's the whatever the command displayed to the screen, so the standard out, std out. Okay, so that should be the end of that script. So now to save it, Control and O, and if you scroll down you'll see it says do you want to write task2.py, so I hit enter to say yeah, and then Control X to exit. So again, to run it, we call the Python interpreter, Python 3, and then we give it the name of the script we wanted to run. Okay, enter the name of the directory, so I'm going to ask it to list the contents of my test directory, and it correctly comes back and tells me that I've got 2 files in there. So pretty straightforward. You'll always be using subprocess.run to execute your Linux commands. Pretty much always need those flags. Shell is true, capture output's true, text is true. That's fully explained in the slides, so please make sure you read that. Okay, one last wee task for this activity is task 3, and this is just to show you a situation you may be in that some Linux commands do involve using quotes, particularly when we want to set some formatting. So for instance, the date command. If I hit the date command, this is what it gives me by default. If I want to display the date result in a particular format, then I can provide an argument which looks like this. So inside quotes, I say that I'm setting the formatting and I want it to have day, then a slash, then month, then a slash, then year, and close my quotes. So by default, this command uses quotes. They have to be there in order for the command to work. And you'll see now it gives me a completely different format than the output the command above. So that presents us with a problem, because how can we tell Python that these quotes are part of the actual Linux command and not part of the Python script? So that's the final problem we're going to look at just now. So we're going to open a new script, task 3, and again I just need to scroll up to get to the top of the file. So again, using the subprocess module, so we'll import subprocess. This time we're going to run the date command, so whatever it returns, I'm going to store it in the variable, the Python variable called date, so I can then look at it. So with the date command, I'm going to store the output of subprocess.run, and as you guys know, the Linux command goes in quotes. So we open our quotes, put in the Linux command. Now I want to put in that formatting that I just showed you, which would look like this. So quote, then the plus, then the %d slash %m slash %y, close quotes. Now that causes confusion because we've now got all these quotes and Python thinks that all the quotes belong to its script, whereas the reality is this quote here where my cursor is and this quote here, these actually belong to the Linux command. So to tell them that they're part of the command and not something that Python has to handle, we need to what you call escape the quotes. So basically it means ignore them. So to tell it to ignore the quotes, we put a backslash in front of the quotes. So we need to put a backslash in front of the first quote and we need to put a backslash in front of the second quote. And now you'll see that my final quote has turned green because it recognises that that's the matching quote for the Python quote that started here. Sounds a bit confusing, but trust me, it will help you if you do end up in a situation where you need to use a command that does require the use of quotes. Other than that, just the usual. So I need to set the shell to be true. We want to capture the output of running the commands. Capture output. Oh dear. Capture output equals true. What I'm trying to do here. Equals true and text equals true. Okay. And then again, we want to take whatever the object is returned from running that command, and we want to look at the actual output of that stood out. And I'll display that to the screen. Okay, hopefully I've not made any typing errors that I haven't fixed. Let's give it a go. So again, Control O, scroll down. It'll ask me, do I want to write? Hit return, Control X, exit. To run the script, Python 3, and it's called task3.py. There we go. So it's executed the command for date in the special format and then displayed it to the screen. Okay, so that covers all of the core areas. What I want you to take from this video is that you're comfortable of understanding how to write your scripts using Nano and how to use the subprocess command and how to execute the scripts. Okay, the next activity 2 and 3, give you a chance to extend your scripting to start to look at including conditions to place on when you run the commands. So we can use if statements to surround the commands, and then we'll progress on to looking at loops so the commands can be repeated. And also, because the programs at that point are getting a bit bigger, instead of just writing the instructions in the script one after the other, we're going to start to organise our code a bit better and organise it into functions. Okay, thanks for listening.